This is Dan again, coming at you with a new problem. And these cars these days are a headache. Got a 2018 GMC Terrain. Came in, power windows don't work. All of them. So what's the first thing that we do? We verify the problem. After that, we try to cover all our, bases. Ground, power, and try to see if we can grab another multi-function switch. Maybe that might work. For this vehicle, I tried all that. I checked out all the fuses, checked out all the grounds, and tried another multi-function switch from a different GMC Terrain. Now the 2018s have a different they have a different style of master switch on the driver's side. I mean, so the second thing that we're going to be doing is we got to grab our scan tool. All right, we're going to grab our MDI 2-axis GDS2. We can't use Tech 2 anymore. That's out of date on these 2018s. So let's go grab that. So picking up the next day, we're over here. We have GDS2 up. So we've scanned the body control module, and we came up with a bunch of codes. The codes that we want to concentrate on right now is lost communication with device on limb bus. Alright. These bottom 4 codes are the initial codes that I had a problem with. That's the ones I picked up. So over here we read them. All of them are lost communication with device on limb bus. Alright, pass and fail. I've already fixed the problem. So at the time when I was looking at it, at the status, it was failed. It was current. Alright, so now let me cut this short, and I will be back with the wiring diagram, and let's take a look at it. Here we have our wiring diagram. I'm going to concentrate on both the front window motors. I'll explain to you a little bit later on why I chose to just concentrate on these circuits. First, we have the 30 amp fuse, which checked out fine. So that'll be circuit 3640 powering up both window motors. One is controlled directly through power, and one is controlled by the passenger switch. Okay, and we also have our 7.5 amp fuse, circuit 1440, powering up our master switch. Okay, next we want to concentrate on our grounds. Ground 201 and ground 205, both checked out. Okay, let's look at it a little bit deeper. So we checked out our powers and grounds. And what's next? Well, we had 3 codes in the body control module, and they're all pointing to the LIN bus being down. Okay, first of all, we have 3 codes, and as you can read them, the body control module lost communication with the window motor on the driver's side, and the body control module also lost communication with the window switch on the driver's side, and also the outside rear mirror switch, and at the same time it lost communication with the window switch on the passenger side. Pretty much when the master switch doesn't have any communication or loses all function, all 4 windows ain't gonna go up and down. Okay, so let's take a look at the wiring diagram for the LIN drivers. Okay, so we pulled up the wiring diagram for the LIN lines. Okay, we are just not messing with one circuit on the LIN lines. We are messing with multiple circuits on the LIN lines. But how do we know which one it is? Well, we follow the codes. okay, and we follow what they say. We pretty much are looking at what lost communication. So we lost communication with the window motor, the passenger switch, and we lost communication with the master switch. Okay, so we go and look on the lens circuits, and here we are: window motor, the window switch for the driver's side, and the window switch for the passenger side. They all have one thing in common. They all share the same wire, pretty much, in the parallel circuit, the green and yellow. Okay, what's our next step? Well, we're gonna isolate the circuit. What's going on with this? Is it grounded to, is it short to ground? Is it a short to power? Is it an open? What is it? All right. So I wanted to hammer this home. We brought up the control module Q code list so you can see what our data is telling us. Okay. On the lens serial data circuit, we can either have one of three things that it's going on: a short to ground, an open / high resistance situation, or we can have a short to voltage. And this covers every single U code from U1500 to U15BF, as you can see, I have highlighted. Okay, it covers our U1534, our U1538, our U1538. Okay, that being said, let's take a look at our next situation that we need over here. Okay, we now know that it's either one of the three things. You either have a short to voltage, a short to ground, or open or high resistance. Where do we go from here? We have wiring from over here through the bottom, runs along the side, under the seats, goes back around, shoots up over, and as you can see, I still have the door panel off. You know, where do we search? What do we do? What's the fastest way to diagnose this without wasting too many hours on this? You know? So where do we start? A good starting point is the body control module. We gotta isolate the circuit, guys. Alright? I already did my research, and here we have the K9. It's disconnected, and as you can see, I'm gonna bring it up close. There's our wire, green and yellow. Alright, that's pin 10 on the body control module connector. Alright, now isolate the circuit, and what you need to do is back probe it. So when we back probe it, what do we got to read? Well, on the lens circuit, we need between 9 to 12 volts. Okay, it's getting power from that 7.5 amp circuit. Okay, let's take a look at it. Here I pulled up the wiring schematic again. So we noticed that the lens circuit is getting power from the 7.5 amp fuse from the instrument panel. Comes back around on circuit 1440 past connector 505 and enters pin 23 on the driver switch. Okay, comes back inside internally and comes back out on pin number 9 between 9 to 12 volts, depending on what's going on in the circuit. Okay, and when you press a switch, it drives the windows. All right, and in that circuit, you know, drops the voltage accordingly. Okay, so when we back probe pin 10 on the pin connector, on that would be considered K9 connector, we've got a rate between 9 to 12 volts. Anything less than that, we have a problem. All right, let's take a look at what a procedure is, our testing procedure on the GM website is. Okay, here I brought up the diagnostic procedure, and pretty much just reiterates what I was telling you guys. We turn off the ignition and we disconnect the harness connector at the control module, setting a DTC. And we're going to test for infinite resistance between the serial data circuit and ground. If less than infinite resistance, repair the short to ground on the circuit. I mean, so what does all that mean? All right. When I disconnected and back probed pin 10, that green and yellow wire, I got 0 volts. And pretty much what it was telling me was it got less than infinite resistance. It means it got, you know, some resistance there. And we need to find out what happened. So we know we don't have a short to voltage. And so it's either one of the things. We have an open somewhere, high resistance, or a short to ground. Okay, so let's go back to the wiring diagram and see what I started to take apart to figure out what happened. Here we brought up the LIN communication circuit, and it's very simple circuit actually, but it causes a lot of headaches, and you got to take apart a lot of things sometimes. Sometimes it's not easy, and you're gonna have to spend a lot of hours trying to figure it out, taking apart things, putting things back together, testing them, and over time you're gonna get quicker and better at it. And especially if you you know, concentrate on one product. Okay, the first thing I wanted to do was concentrate on the driver's door. Okay, it pretty much had more it had more things involved, so I wanted to cover that before I moved over the passenger side. I disconnected connector 500 and back probe that. After you disconnect a connector, you're going to back probe that circuit and see if you get 12 volts now. Still getting 0 volts. So connector 500 was actually over here by this pillar. Consider that the A pillar, I believe, right under the dash, or between the door. There's 2 of them, one lower and one upper over here. Okay, and we could go to this junction over here where basically it ended up being in the mid row, but didn't want to take all that off, so I went to connector 600 and I tested out the circuit again. And now when I back probe pin 10 on connector 9, I had 12 volts again. So what's our problem? We only have 2 left things that could be, or 3 things left. It's either the connector at 600, connector 605, which is the connector along the way on behind the door panel, and or it could be a short to ground internally to the passenger window switch. All right, so let's reconnect our connector 600 back. We're back at 0 volts now. Remember, we're back probing pin 10 on connector K9 on the body control module on the harness side. Okay, we want to move down to connector 605 and disconnect that, and let's see the reading. After I disconnected 605, we've got 12 volts again. Last but not least, we want to connect that back and we want to disconnect the window switch, and now we have a permanent 12 volts. So it started getting really noisy at work, so I took it outside. I'm in my car and I wanted to finish up this this video. So we reconnected connector 600. We went back to 0 volts. Keep in mind we still have K9 connector on the body control module, pin 10. We're still back probing that. We're still getting 0 volts when we reconnect connector 600. We move on to connector 605, disconnect that, check the voltage. Now we're getting 12 volts again. Okay, is the short to ground or high resistance after that, or are we still, or if we already fixed the problem? Reconnect that 605. Now we're getting 12 volts now. Okay, it seems like we fixed the problem, and what I did was I wanted to make sure, and I disconnected this window switch, and we were still getting 12 volts. Now, where did we go right, or where did we go wrong? We could have taken another step, maybe disconnected this window switch, first, or back probe that first, and seen what voltage we were getting. But as you can see, we followed the electrical path, and we disconnected 605. So we didn't make the mistake about that. I mean, we could have taken that. Maybe that was a quicker way, just to pull up the panel and back probe that window switch and disconnect it or whatever, and see what we've gotten. But we did disconnect the 605. We did the right diagnostic procedure. The system went back on to circuit, up to system voltage, and all our power windows started to work normally again. So I concluded that connector 605 on pin 7, as you can see, had high resistance, causing the circuit, the inline circuit, to obviously crash. So there was no apparent short to ground or apparent open in the circuit. Pretty much we just had a high resistance on pin 7 on circuit 605, and I took apart the connector again. I inspected it and I didn't see anything wrong with it. It was just a factory defect. Probably the pin didn't push in 100%, and when I recycled the connector, we got the that line to come back alive. And so anytime we connected that, anytime we had that connected, without knowing, even when we disconnected 600, we disconnected, that circuit running through, that voltage running through pin 7 on connector 605, causing the LIN line to come down. That concludes our diagnostic on this 2018 GMC Terrain. I hope this helps you guys, with other vehicles and similar problems. Did take me a couple hours to figure this out, and I hope you guys like this video, share, subscribe, and comment. Thank you guys.